Assalamualaikum and good day. Welcome back to my lecture. Today we're going to continue to next part, which is we're going to study about the simplification of force and couple system. What is equivalent of a system? In the equivalent of system, we're going to simplify any forces and moment into a single resultant and moment acting at specified point O. Take this as an example in A and in B situation. These both systems are equivalent, where we can see F1 and F2 acting at certain distance of D2 and D'2 on the bar, where at the end hold by someone here. So for that system, we can simplify into one single force, where we name it as force resultant equal to F1 plus F2. Also, we can identify what is moment at A. So moment resultant at A equal to F1 time by D1. Here is our F1 and this is distance D1 plus F2 time by D2. So here is our F2 and distance to point A is D2. So we simplify system A equal to system B. Take this as an example, difference between both systems. In the A system, the force F can move along bar AB, and in system B, F can be along between A and B bar. So both systems going to cause different effect on that bar. So what does it mean? So we take for the first one, the moving force between A to B in the same line does not change the external effect. While for the system B, where F can move between B and A, there is a change in the external. Now let's have a look this example A and B. So A is equivalent to B, where we can see on this pole we have two traffic lights as W1 and W2 at D1 and D2. We can simplify into weight of resultant WR and MRO, where we can identify what is moment resultant at point O. Here is our point O. So our weight of resultant is W1 plus W2, while for moment resultant is W1 times D1 plus W2 times D2. So in this system, we can use these three equations, where the first one is Frx equivalent to summation of Fx, and Fry is summation of F in y direction. While for MRO, where that is resultant couple moment equal to couple moment MC plus moment at point O. So in here, please do read about the force summation, also moment summation. That is the procedure we going to use. Let's see these three forces acting on the plate. We have F1, F2 and F3, and also we have point O. F1, F2 and F3 acting parallel to Z-axis. We can simplify into single Fr on Z-axis, then simplify that into MRO, where we know Fr is F1 plus F2 plus F3. Further, we can simplify that into one single Fr at distance D, where that move from point O to point P. Next, we move to example 4.19. In this 2D force system shown, we need to determine the equivalent resultant force and moment acting at point A. Then we have to find where is the single force location measured from point A. As you can see here, we have 50 pound. Also we have 100 pound and 200 pound vertically. For 50 pound, we have angles given 30 degree, and for 100 pound, we have gradient given, which is 3, 4 and 5. Therefore, to do the calculation, we need to resolve each forces into x and y direction. That means we have to resolve 50 pound and 100 pound into x and y directions. So by doing so, for 50 pound, the angle given is 30. Resolve into this direction, we have 50 cos 30 degree, and into this direction, we will have 50 sin 30 degree. For the 100 pound, resolve into x, we will have 100 times 3 divided by 5. That's into FRX, and resolve into y, we will have 100 times 4 divided by 5. So that FRY. So please remember the proportional method teach previously. So we done resolve those forces into x and y directions. So now we need to calculate what is the summation of FRX, and we take positive to the right. In x direction, we will have 50 sin 30. Also we will have 100 times 3 divided by 5. So we will get 85 pound. Then we need to calculate FRY. We take summation FRY, and our assumption is positive upward. So we have 200 pound upward, so that's positive. Then we have 50 cos 30, that upward, so that's positive, so plus 50 times cos 30 degree. Then we have moving down 100 times 4 divided by 5, so that is negative, so negative 4 divided by 5. Calculate that, and we have our FRY is 163.3 pound. Then we need to calculate moment about A. We take summation moment at A, positive clockwise. So this is our point A. So simply we can cancel out this force, and also force in x direction. This one we can cancel it out because it's in line with point A. So just left 200 pound, 50 cos 30, and 100 times 4 divided by 5. So we check for 200 pound to point A is anti-clockwise, therefore negative, because our initial assumption is positive clockwise. So that's negative 200, and the perpendicular distance is 3 feet, so time by 3. Next we check for 50 cos 30 to point A is anti-clockwise, therefore is negative. So negative cos 30 degree times by the perpendicular distance. So 3 plus 3 plus under 3, so 9. Next we check for this force, 100 times 4 divided by 5 to point A is clockwise, so positive. So positive 100 times 4 divided by 5 times the perpendicular distance, which is 3 feet plus 3 feet, so times by 6. So calculate that. So we have answer is negative 509.7 pound feet, but that one is clockwise. So we convert into positive 509.7. So direction for that is anti-clockwise. Therefore, our MA here is anti-clockwise. So we calculated our FRY and FRX. By knowing our FRX, FRY and MA, we need to find this location, which is we need to find this D. And also by knowing FRY and FRX, we can calculate our FR by using trigonometry. We know our FRX and FRY. By using trigonometry, we can find our FR. So to find our FR, which is force resultant, 85 power of 2 plus SRY power of 2 square root, we get our FR is 184 pound-feet. Then, by knowing our FRY, FRX, and FR, we can get theta. By using tangent, 163.3 divide 85, we get our theta is 62.5. So here is 62.5 degree. And our calculated MA is 509.7 pound-feet. From the basic formula, moment is force times the perpendicular distance. So that means FRX is cancelled out, so just left FRY. That means moment at A is FRY times by D. So we can find what is our D. So our D is 509.7 divided by 163.3, and we get our D is 3.12 feet from point A.